Thursday or Friday? Friday.
It's Friday. I'm taking it on Thursday.
Yeah. It's Friday. Remember, we don't want it after President's Day. That's where it originally was. We're squeezing it in, and you guys are rocking it. So let's keep on rocking it. Let's make it through, and then we can have our review here, test there, and then we'll be good to go. Sound good? If any of you guys have craziness, basketball class the night before, and you need to turn in your homework spiral after the weekend, maybe that'll be all right. Wait, guys, yours isn't until Friday. We'll be fine.
Girls is
But Brandon was reacting. So hang in there. But if for some reason, by us putting the test in, you guys get a little behind and stuff, just let me know. But if you don't practice homework, are you going to be ready for test?
No.
So maybe you're not able to get through all the homeworks. Talk to me about your individual cases of craziness going on with stuff. But otherwise, we got to get through our notes that you guys can get through your practice homework. Okay? Sad thing is, if we're at the end of 7.4, we're on the hard stuff, right?
Yeah.
Someone help me out. What are we doing? What did we start on Friday? Okay, so we're getting rid of denominators? Is that the goal?
Yeah.
Cool. What did I do before? Let me get my little pointer up. What did I do before distributing? Where did this come from?
Oh, boy. It's just
Factors, yeah, I factored the denominator. X had his little partial fraction made, right? With an A like we're used to. Why didn't we keep factoring this guy? Come on, there's at least a few of you that are like, why didn't we keep going? Oh, yes, we can. Come on, x plus 2 times x plus 2. If we FOIL, that totally works, right? No. Nope, not the same thing. We're killing who? Puppies. Puppies, look at him.
Oh no.
He's even waving at you and you're killing him. So stop. So be careful. You guys in the shade today. Anyway, so
It's a hot day, y'all. Stick up with
just a couple of you are like, oh, why don't we just do the difference of squares, right? That works, except what's wrong? X squared what in 4? So therefore, this is what we call an irreducible. Why? Because you can't factor it anymore. Irreducible quadratic factor. So he had his own partial fraction, and because he's a quadratic on the inside, we got to account for him up on top. Remember we wrote that whole table? Well, we didn't. We shortcutted the whole table. But didn't that whole table have, where is it? Where is it? Where is it? There it is. Remember how we wrote about linear factors and quadratic factors? Do you see how, for our quadratic that we have, we had to set up his partial fraction appropriately? Is that making sense? So for linear factors, we get to just put a single constant, A, and now we're calling it B and C and D, but we just have to put a single constant up above. And down here, we have to make it a linear because basically it has to be 1 degree less. So since it's a quadratic, we have 1 degree less up top. Now, let's go ahead and stop talking about why it looks like how it looks like, and let's see if we can finish, solving it. Went too far. The steps are the same. Get rid of all the denominators by multiplying both sides by the common denominator, and then use some of our tricks to solve. Let's get there first, and then we'll talk about our tricks. Sound good? I'll answer myself, yes. It's like returning your own fist pump. Guys, it's so sad. Yeah, look, exactly. Been there before. All right, so when we multiply on the left, they're gone, right? 3x squared plus 4x plus 4. Can you guys be me for a second? What would I remind you as we go to do the right side? Yeah, the x's cancel, but what's left?
the x squared plus 4.
Okay, so nothing's left for this guy, right? He's by himself? No. X is still there. Remember, this whole piece has to go to both terms. And so for this guy alone, as we've shown by expanding in earlier examples, the x does cancel out and this guy's left, but then when we go to distribute it to the next guy, he gets everybody all over again. So the x squared plus 4 will cancel, but the x will remain, right? All right, let's talk about our tricks. How do we keep going from here? What are our options? Let's get that turned off. Okay, we're good. Oh, Brandon, put off there. You're okay. What are our options? We basically have 2 because all of them involve something to do with the system at the end. Sean's
Plug
going
in
for it, no one's gonna
strategic
steal it.
X
Let's go.
values.
Huh?
Plug in strategic X
Okay, so there's strategic X values, or what's the other option?
so they want the constant A's with the A.
Yeah, we haven't done that in a while. Can we do that? Is that alright? Because if you guys look at this, what would the strategic value be? Yeah, either if you solve, Karina's looking at this one. If you solve this guy for his zeros, wouldn't it be plus or minus root negative 4?
Mhm.
Ugh. We don't want root negative anybody, right?
Yeah.
Okay, so his are imaginary. What's his 0?
0.
Yeah, his 0 is just 0. I guess that could kind of work. But if you guys notice, if you plug in a 0 here, that's all fine. Well, 0 might work. We might come back to him in a little bit, okay? Hold on to that strategic x equals 0. But let's talk about the whole grouping thing. Ready? On this side, we have an x squared term, we have an x term, and we have a plus 4. Do you guys see, when we go to distribute, that we're going to have an ax squared over here and a bx squared? Right? We're going to have an ax squared from here, and we're going to have a bx squared from there, right? Now those are all the x squareds. What else are we going to have? We're going to have a cx, right, from right here. And then we're also going to have from over here a 4a. Yeah.
So, can you say that C is 4 and A plus B is 3?
Yes. I hadn't gotten there yet, but yes. Let me go ahead and show what Luke is saying. Ready? We can look at the x squared and we can say, hey, those are x squareds, right? Now this is weird. We're not used to doing this. So if you have x squareds on the right, x squareds on the left, well, they must equal each other because a, b, and c, and we know are constants for sure. No x values involved. We have an x term, we have an x term, and we have a constant and a constant, right?
Yeah.
So can't we set up a system and say, okay, a plus b must be 3. How'd I get that from? Which color? Yellow, purple, or green? Yellow. Look at it. A plus b, the constant coefficients, a plus b must have made 3. Right? A and b put together must have made 3. Does that make sense? We could write ax squared plus bx squared is 3x squared and divide everything by x squared, but that's an extra step. What else can I write? What else can I write?
4 equals 4A.
Does that make sense? So c equals 4, good. A plus b equals 3, good. 4a equals 4, good. So we already know 1. If we divide both sides by 4, we know another one, right? A equals, how do we get the last one? Plug it in, right? So 1 plus b equals 3, so yes, b equals 2. Now, if you guys noticed a second ago, we only had one strategic x value and how many variables? 3. How many strategic x values would we have needed to have had? Have we not talked about that yet? You would have needed 3 strategic for 3 variables, right? Wasn't this process a little bit faster this time? So, I just wanted to remind you guys, because we kind of got into liking the strategic values on Friday, because we're like, sweet, let's just plug in, stuff goes away, we solve. Let's just plug in, stuff goes away, and we solve. Let's just plug in, stuff goes away, and we solve. However, I wanted to remind you guys about the like terms, that we can group by like terms, and that might be as easy, if not easier. Now, sometimes it can get hard, but so you know it's there. Does that make sense? Let's go ahead and see one last example, but any quick questions? Wait, we haven't finished writing our answer. What is our answer, guys? Good. So plugging in a above x, plugging in b next to the x term, plugging in c next to him. Now, could we factor out a 2? I suppose. But we're going to calculus. Let's stick it to the man and say our time's too precious, yeah?
Yeah.
If the back of the book had that 2 factored out, would you guys be good making it match? Good. All right. All right. Last example. do you guys see?
Then proper number.
Ooh, let's divide. Wait, is it?
Wait, no, it's x
Oh.
squared
Yeah.
squared.
No, but that's exactly what I wanted, Luca. That was perfect because some of you would say it's improper. Top wins if you even remember to check. But some of you are like, oh, there was no shade. You guys are ridiculous. Okay, so coming back. But if you look at the bottom, what degree is this really? 4. Ah, so let's not divide and waste time with that. Okay. So what do we do instead? Factor. Nothing for step 1, you're right. Don't divide. Step 2, factor. What are the zeros of this guy? Imaginary. Oh, I can't factor anymore. He's irreducible like the last one. Alright, well I guess we just write him.
A over x squared plus 2, b x plus c over x squared plus 2.
I'm going to write it twice, which reminds me I need to have 2 partial fractions. This case, guys, they're not distinct quadratic factors. I know, it's misleading. They're repeated. Wait, why are they repeated? Do you remember what we do with repeated factors? We write it once and then, ooh.
The power of 2.
Yeah, you need 1 to the power of 1 and 1 to the power of 2. I know it's tricky, but the nice thing is the same thing you do with repeated linear factors, you do with repeated quadratic factors. The first we had to figure out we couldn't go anymore. Second, we had to realize it was repeated, make 2 partial fractions, and we had to remember the process. So you make 1 factor and then both factors. Since they're both quadratic, yeah. Luke's already starting to say it. What goes on top?
A over x squared plus 2 and b of x plus c.
Almost. Almost. You're looking here for your guide. You need to look here. Don't both of them have quadratics on the inside?
A of x plus b.
Yep, you got it. We need an ax plus b on this one. Aw, sad day. So who's this guy gonna have?
c of x.
Yep. Ugh, there's so many variables. All right, we got to use all our strategies on this one, guys. We have 4 things to solve for. And do we have any strategic x values? Ah, they're all imaginary. We got nothing. Well, let's see what we can do. What's still the first step?
Multiplied by
Yep, multiply both sides by the common denominator, which means everybody. X squared plus 2 squared. X squared plus 2 squared. On the left, they cancel. True? On the right, let me rewrite that. Actually, do you guys want to make it easier? Karina already pointed out, and some of you probably saw it. Couldn't we technically pull out an x over here to maybe split things up a bit? And not write 8 as 18? Okay. Not saying you have to, but you can. I think that probably make multiplying a little bit easier. Over here on the right, when we distribute, do you guys see how we're going to get only one of those factors left, x squared plus 2? Is that okay?
Yeah.
Remember, one of these is going to cancel with one of those.
But I think if you leave it ax to the third, it's going to help you because you have ax to the third. If you don't factor out that x in the first term, the left side,
Oh, it's going to be easier?
you will eventually have ax to the third, so you already see the similarity.
True, true. Luke is saying like, hey, there's going to be a cube term, so maybe you need the cubed and the squared and the single and the constant. So we'll see. That's if we start right away with finding the like terms. We might not want to do that, and I'll show you why in a second. Hold on, we got to finish. Does cx plus d have anything else? Nope, he's on his own, right? So do we technically need the parentheses if it's just addition? Doesn't look that bad. What do you guys want to do? Do you want to like term it, or do you want to strategic value it? Like term it? Okay, let's like term it. The strategic value, there's like, I don't see any nice numbers over there. I do see maybe x equals 0, but don't we need like 4 strategic values? The multiplying by 13 and cubing it, no. All right, how do we like term it then?
Should you distribute that?
We distribute the x, all right. So we know there's going to be a cubic, there's going to be a quadratic, there's going to be a linear, there's going to be a constant. What do I have to do to the right side? I'm just going to write them whatever order they come so we don't get confused, all right? So I have plus 2ax, I have plus bx squared, I have plus 2b, plus cx, oops, not 2. We got everybody, right? Let me go ahead and zoom out, zoom in. Now you guys might not have colors. If you do, that might be helpful. If you have a 4-color pen. If you want to rearrange them, you can. I'm just going to be lazy and go find me. There's an x cubed. Let's see, where are the x terms? There and there. And an x squared. Uh-oh, there's no x squared on the other side. Does that mean we fail?
No, there needs to be 0.
What'd you say again, Luca? That means what?
B would be 0.
Hey, if it's not there, it must have been 0, right? Okay, hold on. Let's start with the cube. Let's work our way down. Is that okay? I see 8 for the cubed, right? Who else is the cube? That's it, right? The yellow? A must be 8. All right. Let's move to, can I move to the squared? So green, B, wait, there isn't one. Oh yeah, so Luca, what is it again?
0.
0, because there is, you can think of it, no x squared. Does that make sense? What else is there none of? The constant. So you could think of, for your constant, that's just going to be 0. And for your, what was the x squared green? If that helps. 0 equals b. Now we have the x term. 13 equals, what do you guys see on the other side? C and?
2a.
2a. 2a plus c. Remember all the purple ones? And then we have 0 equals. As long as the multiplying is pretty fast, this method is kind of nice. If there aren't any like really easy strategic values. So we already know him, right? We already know him. Now what? Plug it in for A and plug it in for B, yeah? So we have 13 equals 2 times 8 plus C. C equals, can we mental math it? Negative 3. 13 minus 16.
Yeah.
B equals 0, so we're like, all right, fine. 0 equals 2 times 0 plus B. What do we got?
0.
How we put it all together, we say, oh yeah, that's right. Our whole point was to fill this puppy in, yeah?
To check in or just plug it in from the beginning?
To check, technically, you could plug it in at this step right here and make sure it all matches, but to really, really check, what you would do is first compose your partial fractions. So plug in your 8x over x squared plus 2. I plugged in b is 0, so he's gone. Plus c is negative 3. Because technically, Luca, if we do plug it into this step right here, we could have made a mistake to that step. So to truly check, I would say take this and get a common denominator. You know what I mean? When you get a common denominator, what had it better match? What we know for sure is right, the question. But remember in homework, sometimes it's easy to write the question wrong. Who's done that before? So if you write the question wrong, you have to be going back to a faulty conclusion. So make sure you write the question right. That's the first step. Read the question right, write the question right, then go. Hey kiddos, with that, where did we just finish? 7-4. And as Lucas said, you could have done most of the homework over the weekend. We said there might be a couple tricky ones that would have stumped you. But now I think we've done an example like pretty much everybody. Either you have non-repeated linear, or you have repeated linear, or you have non-repeated quadratic, or repeated quadratic, or some combination of all the above. We have our strategies of the like term approach. which is matching them all up and setting little systems of equations. We have the system, or I should say the approach of systematic values. Strategic, why did I say systematic? Strategic values, plugging in, things will cancel out, and then we need to solve. Both of them are good, both of them are valid. Just depends on the problem and what you're feeling like, basically. Anybody else still working on this one? Couple more seconds. Guys, new section, new side, 7-5. Oh, how could she expect us to do it in 16, 15 something minutes? Just you wait until we see what the section is. You good? Oh no, where is he? Hold on. He's not showing up, we should say. Uh-oh. Let's try again. Title! Section 7-5, new section, new side, systems of inequalities. Dotted line, solid line, shade up, shade down. Some of you reviewed that without meaning to. P.S. Speaking of helping out, speaking of Algebra 1, because they're learning systems of inequalities, or they have done it recently, they have a test tomorrow. They need to do well on said test tomorrow. They might not do well on said test tomorrow unless they get some help. I am going to strongly encourage them to come in during lunch or after school. And if any of you are here available to help, whether or not I actually have a student to give to you, you will get an automatic half hour for free on your tutoring sheet. Now, if there's a student, you can help them on things like exponent rules. X squared times x cubed is x to the 5th. Things like that, and of course they get trickier. But also, actually system of inequalities was chapter 5. They just did test corrections on it. Also, let's see, exponential equations, how to graph with a table. They don't have to have memorized the graph. They'll swoop up like an e to the x, or swoop down like a e to the negative x. What else? Growth and decay, which might sound kind of hard, but there's really just a formula that you peek at. It'll be in their notes. And let's see, what's the last thing they talked about? Geometric sequences with common ratios. Can you figure out what the pattern is and find the next few terms? That's basically what's going on. So, their chapter review shows an example, has a few problems, shows an example, has a few problems, like the Algebra 2 book last year. I have full confidence that you guys can do it. So if you are trying to meet tutoring hours, you can come eat lunch in here during lunch, and if there's not a kid, I'll just give you a half hour and you can leave. Or you can come in after school and be available. If there's not a kid, I'll give you a half hour. Okay, systems of inequalities. How do we do it? Sketch the graph like an equals. Take the point that is not on the boundary line. If it works, shade it. If it doesn't work, don't shade it. We are throwing shade. Anyway. You're welcome. You guys practice?
Oh, we did.
That was a sign. So you guys are getting the steps real quick, but I have it in green because this entire section is review except. You're not just graphing lines anymore. Not in Kansas anymore. Sketch the graph. Sketch the graph of, who's this guy? Who's this guy? Y is greater than or equal to x squared minus 1. Who is he? Parabola. And he has been?
Shifted down.
Down 1. Solid or dash?
Solid.
Yeah, because it's or equal to. If you see the line, make a line. Make a solid line. And how do we finish this puppy? We could make it more precise, of course, when x is negative 1, x is 1, x is 2, x is negative 2. Plug in a point, and what's a good test point? 0, 0. He's not in the boundary line, and he's easy. So test is 0 greater than or equal to 0 minus 1. Mental mathers?
Yes.
0 greater than or equal to negative 1, and the answer is
C.
yes. So what are we going to do?
Shade.
We're going to shade where he is. What if it was false? What would we do?
Shade on the right.
Shade on the outside. See why I said 7-5 shouldn't take as long? Exactly. And then we're good. It's much more polite to throw this kind of shade instead of
I didn't say anything.
poor kid.
She laughed.
Throwing her to the bus. Can I keep going? We good? Is it going to get any harder? Oh, I don't know. Solving a system of inequalities. If it's a system, all that means is there might be more than one. Oh. Well, if there's more than one, we just have to figure out the overlap, right? Which means you might want more than one color. Of course, that's always kind of fun. Hopefully you have something. If worse comes to worse, you can use your grading pen and your pencil, right? Unless there's 3. Ooh. Maybe a black or blue pen. Unless there's 4. Highlighter? Or we'll go find some colored pencils. Okay. Multiple conditions are involved. Solution has to be something that's true for all of them. Sketch the graphs of everybody. Everybody find the common, what's in common, or the overlap is another way of saying it. Ooh, can be helpful to find vertices of solution region. Vertices. I'll give you guys a second as you're writing. Vertices of solution region. That's kind of new. Let me help with what I mean by vertices real fast. Vertices. And I think we'll talk about it actually in the next section as well. When I mention vertices, what I'm talking about is intersections between pairs of inequalities. Now you guys might just have 2 inequalities, so it's not a big deal, but if you have 3, you might have to pair it up like the first and the second. You can't spell and talk at the same time. Okay. First and second, second and third, first and third, you might have multiple vertices when you pair up differently. But I'm just talking about the intersections, which are like, hey, forget the inequalities for a bit, pretend they're just equations, and what would the intersections be? What would the solutions be? The inequalities, remember that's the shading on top of the boundary lines. So we'll talk more about that, I think, in next section. And guys, really, section, if you guys are a little bit worried, section 7-6, I think, are just kind of let's apply everything we've done to maybe a few word problems. So it's not really anything new mathematically speaking, I don't think, if I remember right. You guys almost have them? So vertices are solutions between pairs and just the intersections. Okay, we have an example. And then pretty much my notes are done. One example, notes are done. Okay, so hang in there. Vertices, intersections between pairs of inequalities. The last thing that was on there, vertices, were intersections between pairs of vertices. Oh. Intersections between pairs of inequalities. All right. We got ourselves some inequalities, and specifically speaking, 3, yeah? Sketch the graphs, label the vertices of the solution set of, oh, we gotta do all sorts of stuff. It's okay. We got it. Let's start with sketching the graphs. That might help, huh? Graph number 1. I don't like his form. Do you guys? Not that I don't like it in a judging way, just like we can make it better for our purposes, right?
I'm judging.
Y greater than x minus 2. Have you guys solved for y yet? Careful. If you decide to subtract the x from both sides, that's not bad or anything, but when you divide or multiply by a negative, what happens to the inequality? Has to switch. And then we have inequality 2, we'll keep them the same because there's not really anything we can do. Inequality 3, we'll keep the same because there's not really much we can do. But we can have some fun with colors. It'll be green, it'll be blue, for me anyway, and it'll be, make it bright. How do we graph a line?
Draw a line.
Yeah, sounds good. So we have to make our intercepts, right, and our slopes. So, making the green one, we start with the -2, true? Up 1 over 1, up 1 over 1, up 1 over 1. Solid or dotted? Dotted, because there's nowhere equal to, yeah? You guys remembering? It's coming back. Ooh, where do we shade? Can we test 0, 0? Is he okay? Not in the boundary line?
Yes.
Yeah, he's not in the boundary line, so let's go ahead and plug him in. Is 0 greater than 0 minus 2? The answer is true. 0 is greater than -2. Does that make sense? Cool. Equation number next one, blue. Ooh, how do we grade x is greater than or equal to -2? If you've always struggled with this, x, -2. Isn't that right here? Just follow the tick mark. Exactly. Just follow the tick mark. There's -2. Dash because it's not or equal to. Just follow the tick mark. Tells you all you need to know. Shading. 0, 0 is still not on the line, so let's go ahead and plug him in. Plug him in. 0 greater than -2. I'm seeing some overlap. How about you guys? Cool. Last one. Y less than or equal to 3. Go to the tick mark on the Y, and what do? Follow him. Why is he solid?
Because it's or equal to.
Exactly. 0, 0, not on the line. 0, less than or equal to 3. True. They've all been true, right? True and true and true. So let's go shade where the 0 is, which is below.
So on the test,
It was
should we have,
gorgeous.
like, a better-
Now, on the test, this is what I told my Algebra 1 kiddos. They didn't have one this hard, of course. I said, find the overlap and pick a 4th color, if there are 3. Technically for them, it was a 3rd color because they only did systems of 2, of course. But now we can make it clear, 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 clear. And this helps you because we were supposed to graph and shade, but weren't we also supposed to find the
It's a
vertices?
right triangle.
It is a right triangle. Gee, we could do some trig with that. Woo! But question, do you guys see the vertices I'm talking about? Intersection between pink and blue. Intersection between pink and green. Intersection between blue and green. How do we find those if we're not graphing super precisely? Oh, now what?
Find intersection points.
How?
By doing all this stuff in my.
Can we call him 1, call him 2, and call him 3? For 1, who are we looking at? Blue and pink. Wouldn't that be x equals -2 if we were just looking at the line itself? And y equals 3? Okay, I already got it. If we're looking at blue and pink, it must be the point -2, 3. Vertice number 1. For number 2, what 2 graphs are we looking at? Pink and green? So we have green, y equals x minus 2. We have pink, y equals 3. Remember, change your inequalities to equals. Oh wait, if we know y, can't we plug in and solve for x? So then plug in 3. 3 plus 2 is 5. You guys get it? And how do we find the 3rd vertice? Graphs, green and blue. So we have y equals x minus 2, x equals -2. We have x, go plug it in, -2 minus 2 is -4, right? So -2, -4, dun, 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 dun. We got our graph, we got our 3 vertices. We're out of here, almost. Questions? Yeah, Kristen.
Where'd you get the x equals, or y equals x minus 2?
Oh.
For the thing.
Check it. We were looking at the green graph. So I took him, but remember we ignore the inequality and we make them equals instead.
Okay.
So we took our y, but equals x minus 2, or x equals -2, or y equals 3. Does that make sense?
Yeah.
And we pair them up based on the colors that we see. There we go. Technically the arrow should be the other way. With that, kiddos, yes, it was that short. Oh look, it's just showing us that we got it. Oh wait a minute, why did they put holes here? This is the last thing. Why did they put holes and they didn't fill it? Oh, I got dotted coming in, I got 1 dotted and solid, so if I put them together it must be empty, and then dotted and solid, if I put it together it must be empty. The only way we can fill the vertex or the vertex is if they're both solid. Otherwise, that's solid. Here we go. Wow. 7-5. Alright, cool kids, work tonight on finishing 7-4, 7-5, have some fun with colors. Coloring homework. Go team.
Nice section.
We like these ones. Alright guys, 5 seconds, relax, get ready. 4. Happy Monday, hang in there, cool kids. If you do anything, let me know. I'll see you later.
And then I was like, I don't even know how.
Thank you, Amy.
What time?
It's been like,
You don't know yet?
yeah, I
They knew you were dead.